I'm Paul Rako. This is the Atmel Edge, the show that makes you well-rounded and well-grounded. This show is for engineers, makers, hobbyists, technicians, anyone who wants to learn about system-level design. Even mechanical engineers might learn a thing or two. Today's show is Schematics 201. It's a level higher than the Schematic 101 series, where we talk about grounds and capacitors and resistors, things like that. This show is trying to get across the fundamental rule of good schematic design. That is, schematics have a flow from left to right, from top to bottom. We're going to show you some examples, and there'll be a couple other tips about good solid schematic design if you want to do good professional work. So let's get started. Okay, Schematics 201. The most fundamental thing about a system level schematic is that there's a flow to it, and that flow is from left to right and from top to bottom. This way anyone can pick it up and they know they can look at the left edge and tend to see inputs, or look at the top and tend to see inputs, and then they can look to the right edge or the bottom and tend to find outputs. It's not that simple, because what about a bus? How do you represent something that has bidirectional flow? Do you put things on the top or the left edge? Questions like that, well, that's kind of a style, but if you just stick to these basics, you'll be a lot better off. To demonstrate how confusing it can be, this is a little bit of a cheat, because this isn't really a schematic. What this is here is a wiring diagram for my 1996 Harley-Davidson Sportster motorcycle. And it's kind of, I'm purposefully leaving it a little rough because I don't want to violate Harley-Davidson's copyrights. But this isn't a schematic. It's not telling you the scheme of things. It's a wiring diagram that kind of shows not where things are, but a physical representation of the gizmo. And then this crisscross, they don't break connectors up, which is a common thing you do in schematics. If your connector has inputs and outputs, it's not uncommon. OrCAD, a lot of CAD packages will let you break that symbol and put the output pins on the right-hand side in a little wiggle to show it's part of a connector. So this diagram, you can see there's physical representations of the battery, the stator. Well, already I'm kind of have a problem, because the battery and the stator are an input kind of thing. They're the fundamental beginning of the electrical system in an automotive vehicle. So I wouldn't put them over here on the right edge, but that's kind of up for choice. Once again, this isn't trying to be a schematic. It's just trying to do too many things. It's trying to show you how things are hooked up and kind of what they look like, and not so much where they are. So in my mind, this is the worst of all worlds. So years and years ago, I redrew this, and this is just one page. This is the main harness. There's a whole another page or two showing the handlebar harnesses and all of those wiring diagrams. So this right here, let's take this off. And that was a B-size drawing. In the manual, I think it's taken from the service manual. It's a little bit smaller. It's probably a sideways A-size. This is an A-size drawing I made years ago that has all the information of two of these wiring diagrams that Harley-Davidson does. This is a true schematic, and you can see, and a lot of choices. I put the battery in the top left corner because I figured that was the energy storage, the most fundamental input to the vehicle was the battery. You need it to start. And I played around for weeks just trying to arrange this to get a semi-optimal thing for an electric start motorcycle. You might not do it this way for a kickstart motorcycle. I got different schematics for those. Also on the left edge, well, the alternator stator. That's another fundamental input to the vehicle. Once it starts, then this is creating voltage. And then everything just fell out of this really nicely. I did representations of, to me, outputs. Here's all the lights. Here's the tachometer. Here's the speedometer. We have the ignition system, the ignition module, the coil, the two spark plugs. The starter, which I consider an output. The starter is where you send the power that then does mechanical work. So all of those things are on the left edge. And one of the things I do, again, a style thing, a lot of people get upset with this big jump, you know, over a bunch of wires. This is done in AutoCAD, so I could put in wire jumps. Now I use TurboCAD. In OrCAD or the CAD packages, you're kind of stuck. I notice I left out a wiring dot where right there. Got to put dots at your junctions, and don't do four-way ties. That's against ANSI Y11. And the reason you don't do a four-way tie where there's a wire connected here and a wire connected there and a dot in the middle, a couple copy machines, a bad JPEG, and all of a sudden every cross looks like there's a dot on it. And if some places you do have a dot between a four-way tie, nobody knows, well, is that really a connection or is it not? So top to bottom, from left to right, no four-way ties. That's Schematics 201, and that'll go a long way to get you started. Okay, for a little bonus feature here, I want to show, we'll go back to that Harley-Davidson wiring diagram. Can't get too mad at them, it's not trying to be a schematic. I would hope they've got something like my schematic in the engineering department, they just don't publish it. So this wiring diagram, you can see it's confusing. There's too many, there's all this open space with wires crossed and what's going where. And you can see other people have tried to improve it. Now here's a little color that helps, but you have to be careful about using color. I've read, I'm not sure it's true, I've read that 40-some% of Asian males are red-green colorblind. So when you use color to encode information, it's not a universal thing. You should maybe use dashed lines or triangles or something. So here, more of a physical representation. Still things I think are crazy, like a light is an output. What's it doing on the left edge over here? Other things that I just don't like is the clutter, and this one at least shows the handlebars. This is what, XLS, this is an older Harley Sportster, 84 vintage. It's such a nice drawing, I assume this is a factory one. That's why we're not going to let you see it too clearly and violate the copyright. So online I found some other things trying to get around this problem, how hard it is to understand. This I think is for a Japanese bike. Notice there's a whole thing's missing. This is going to the engine control module. So this is just a connector or some junction going up to the engine control. Once again, very physical representations, not schematic symbols like an electrical engineer might see, but a physical representation of the battery and things like that. And finally, I want to bring out a special case where, because semiconductor people publish a lot of app notes and that, there are a lot of schematics floating around out there where the chips are numbered in order. Now, that might be fine for a bonding diagram where you're trying to connect the die to the pin, but it's absolutely wrong to have your chips drawn like that in a schematic, unless just coincidentally the chip happens to be designed so the inputs are on its left edge and the outputs are on its right. So this is an example of bad schematic, and the first people I saw doing this, to throw a few stones, it was Maxim. Their apps engineers thought that you should number the pins in order. So now, once again, this is trying to do too much. It's not the scheme of things, it's not a schematic, it's half a schematic and half a layout, showing you maybe how you'd route the wires or where you'd place things next to the chip. The first thing is you need a schematic with inputs on the left, outputs on the right, inputs on the top, outputs on the bottom. And this doesn't do that. So that's why OrCAD, Altium, all the CAD packages, you can get into that symbol for the chip and move it around, put the pins on this side. OrCAD 9, the old OrCAD, makes it trivial. You just right-click, edit part, and then you can move pins where you want them, so your schematic does flow the way a good, professional, system-level engineer would have their schematic. So that's a tip for today. It's a little bit higher level than just grounds and capacitors and resistors and things we're going to talk about in the 101 series. This is Schematic 201. I'm Paul Rako. This is the Atmel Edge. See you next time.